Hey y'all, my name's David. We're here at the Rutgers Core Repository. We have in front of us the Minalyzer XRF scanning machine. XRF stands for X-ray fluorescence. What that allows us to do, and what we're doing here at Rutgers, we can use the scan drill core along the length of the entire core, and it'll tell us at each point along the core different elemental concentrations of elements ranging basically from sodium to uranium. We do two sets of scans, a low voltage and high voltage, with the median in between the two being around the iron range. These cores come from the Newark Basin here in the New Jersey area and cover a history between 200 and 220 million years ago. What we're hoping to do on the academic side is, after covering this entire about 20,000 foot section of cores, is have a good amount of information about the history of the aquatic chemistry going on in the region, the changes in the climates which have formed the depositional environments. We're looking at certain astronomical constants and seeing cyclicity in the movement of planets. Kind of out there, but I think a lot of cool stuff's going on. The way this works, if you want to take a look inside real fast, you can see that we have a mast that moves along the length of the core, a detector tip, which at each point takes a measurement on the data. We have just finished a scan on a set of two boxes, so you're going to get to watch the process of putting two new boxes in. I have found it to be quite easy and quite efficient. So here on the screen, we'll start up the next scan. This is all from scratch. We're doing boxes number 149 and 150. Just going to change the settings up real fast. As you can see, this process is quite easy. The interface is very simple to understand. Even I, as an undergraduate student, can handle it with ease. Quite a few of us here in the department, back in our prime, we had about 8 interns, all staggered operating the machine, getting experience, and what is usually used as a mining industry geolocation and mining engineering device for mine drill core. We're using it to analyze legacy cores. So we're going to take the cores out. These boxes they're heavy, about 45, 50 pounds. Put a look on our cart here. Piece of cake, especially after some time. You really get a feel for it. Just pulling them right out. Just like that, we will load up the next set of cores. Like I said, this is 18 feet going in all at once. Sitting here within the tray. To continue, what the machine does next is it goes through, does a laser profile of the depths of the cores. And with that, it'll generate the path along which the detector will travel. You can see in there, hopefully on the video, the laser passing through. After the laser passes through, we will generate the path, which you will see in the screen in a second. And it takes a series of photos, which is stored alongside. That way you have easy reference points for the depths. You can see the textures and colors. And of course, demonstration purposes for really interesting regions. A project we did recently that was not this one was looking at the PETM, Paleocene Eocene Thermal Maximum cores, which is a very small section, which was this section of interest, with a couple more feet on each side, and that particular region in the center was this region of interest. We have a good photo of it to show people. Now, the speed along which the detector moves across the core, we have it set to 1 centimeter a second. That can be changed depending on what kind of resolution you want, and of course what your throughput needs to be. We found a throughput of 1 centimeter. We made it to be good. We are getting through about 4 boxes an hour. On both our low and high scans, that means we're doing about 36 feet an hour in scans, which is pretty good. Now if you come in here, you'll see the elevation profile is done. We can go ahead and generate path. Luckily, this section of core is in pretty good condition and should generate a clean path with ease. You can see the red sections are along which it would like to scan. Blue sections is a change in elevation just from cracks, something that it's not going to scan and wants to overpass. And I think that looks pretty good. I think we're ready to go. Just kidding. We've forgotten the most important part. We're using a tank of helium as the gas in the container, which I'll flip the switch in the back here. You can see our tank right here. It's flowing right in. This ensures that the atmospheric gas does not get detected and we get a clean detection. And just like that, ready to go. You've gone through the whole process. In fact, you probably understand just as well as I do how to operate it. The scan's going to take 16 minutes to go through the low voltage. Once again, we will do a high voltage scan through that, another 16 minutes. It comes out to about 32. And it's been a few months. We've gone through a lot of core. We're producing a lot of data, and we're going to keep doing so. It's been, for me personally, a really good experience getting to obviously operate the equipment, but also see data quite quickly that I got to produce in a sense, because I put them in, I prepared them, I cleaned them, and as far as a student perspective goes, it's been great. As far as academic perspective, this data set is unlike any other. I don't know of very many that are as large. I know that there are some that are equal in their resolutions, but definitely not in throughput. This is, I think we've got like 3,000 boxes. It's insane. As far as that, I think we've covered everything in the operation and the benefits to, let's say, a university or department looking to enrich its students and produce amazing data.